Now we come to a new session which is called integration. In integration, we have two parts. One is called indefinite, and afterward you have a definite integrals. But it doesn't matter, so let's start about the idea of integration first. Integration is highly related to differentiation that you have learned in Form 4, and then so which is talking about which is also talking about a big branch in math called calculus. So which is also a core part you have in mathematics, core part in mathematics M2. Calculus you also need to know the Chinese term, so it is called 微積分. So differentiation is talking about 微分 and integration talking about 積分. So when you look at the Chinese term called 積 is something about product, or later on you will find that it's about area and volume. Okay, by the way, so let's see the big definition of integration first. So we have two objects, one is called big fx, the other one is called small fx. So they are defined as differentiating the big one, and then you have the small fx afterward. So if you want to resume fx to the capital letter fx, so we use a symbol, integration. So it would be a very funny symbol because it is written as, it's like a snake, and then so you have the content here, and then so you have a dx afterward. So that's the symbols of integration. One more interesting thing is, compared with differentiation, the outcome of integration is not merely a function, but there's a constant c. And then so we will talk about the meaning or the reason of having c afterward. Next, so you still remember I said integration is like resuming to the big letter fx. So that's why we have a name for the capital letter f, x, which is called primitive function. And then now we come to have a look on why we have a c in integration. So I gave you two very simple examples. For example, differentiating xy give you 2x, while differentiating log x is 1 over xc. Yet you will also see that if you are differentiating x squared plus 1, so because of differentiating 1 is a 0, so that's why it's equal to 2xc. Or like if you are differentiating x squared minus 10, and then again differentiating minus 10 is a 0, so it gives you a 2xc. So similarly, differentiating x squared minus 7, for example, so it's also 2xc. And you will see 2x, 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 2x are the common results of the differentiation as follows. So that's why when we resume integration of, when we do integration of 2xc, that means we want to resume and get its primitive function. We don't know whether it's simply x squared minus 10, x squared plus 1, or x squared minus 7. So as these numbers cannot be found except further information should be is given. So that's why we will be write as the answer is x squared. While the number coming up we don't know, so that's why we say c. And then we specify that where c is a constant. So there's one of our very simple example to explain to you why we have a c in the result. Similarly, so if you can't understand very well, and then so you take a look on log x as follows. So if you're differentiating log x minus 1, and then so it's still 1 over x. Differentiating log x even plus 100, so it's still 1 over x. So that's why when you resume 1 over x to its primitive function, beside log xc, we don't know whether there is a number like minus 1, 100, or even nothing after log xc. So that's why we add a c as a result of integration, and you have to specify that c is a constant afterward. In public exam, it will be safer for you to write down this phrase where c is a constant, where c is a constant, because to avoid having any poor presentation in the public exam. But in the notes, in the examples as follow, because we need to write this sentence many times. So to our convenience, I will skip this sentence afterward. Okay, coming up next, there are two very simple properties of integration, which is if you have constant, it can be taken out. If it's addition, subtraction, you can cut it down and integrate them one by one. The most terrible thing is product. Don't expect that we can integrate the product one by one. For example, like integrating of fx, integrating of gx, etc. is totally wrong. Similarly, if it's a product, then you can't integrate them one by one as well. So that's why later on you will see that integration is very difficult because we have some special ways to deal with product and portion afterward. Anyway, so let's take a look on example 1 and see how some very simple question of integration can be done. Next, take a look at example 1. The way to do integration would be you think of its inverse. So you're thinking of how can I get 2x in differentiation? So that means d something will give you 2x. So what should it be? So as a result, you think of is x squared. So that's why it's x squared plus c for the outcome. Now coming up next would be, so you think of, so differentiating of something equal to 3x squared. So now retrieve your idea in differentiation and the result is x cubed. So that's why it's equal to x cubed plus c. Next question you can see is talking about sum. So as a result, you can go back to property 2. So when you talk about sum, you can integrate them one by one. So that means the result can be written as integrating of x and integrating of x squared. So now you'll find the result one by one as follows. Differentiating something would be xc. So you can only think of differentiating x squared is 2x. So that's why in the result, and then so we rub away the 2, but we can put 1 over 2 in the front. So that's why it's 1 over 2 x squared. A similar idea comes when you look at the second expression. So you have differentiating of something gives you an x squared. Now you can think of differentiating x cubed is 3x squared. So that means you take away the 3, but you put the 1 over 3 together with x cubed, and you have 1 over 3 x cubed afterward. So at last we just add a c to put together all the constant which may generate it, or which may be result from the two integrals, and then so here comes the result. If you're fast enough, later on you can skip this step and you just write the answer directly. Okay, coming up next, so you have d, so which you may think of integrating of 1 and also integrating of cosine x dx. So now it comes to, so differentiating something which gives you a 1. So hopefully it's very easy to you, which is xc. Okay, next you should have differentiating something is equal to cosine x. Oh, you have a hard time because you may forget the result of sine cosine function. So the answer should be sine x. So afterward is x plus sine x plus sine x plus c as a result.